Okay, now having gone through laboratory management and organization, now the next procedure or the next stage is to make sure that in accordance to the National Examination routine, the National Examination Council of Tanzania has been providing the apparatus checklist, which is purposely to ensure that it prepares you, the laboratory technician or the teacher, to make sure that all the possible apparatuses and materials are available during national examination. So now what we do here is to prepare. Mind you, we have 3 hours instructional procedures to make sure that you can prepare all the required materials and apparatuses possible. But to make sure that time is efficiently managed, you need to attempt pre-preparation procedures. One of it is to ensure that you have prepared or ensure that all the required materials, apparatuses, and equipments are available in accordance to the National Examination Checklist. So now here, I suppose the checklist is yet with me. My first purpose is to make sure that I prepare labels. And we have different principles or ways of preparing labels. We can use a masking tape. Here, in most cases, we use a masking tape to label hard materials like wires and the other related materials. But we can use instead the tape, the salt tape, which is a transparent tape. This is mostly used to label, just in case you have decided to use pieces of papers. You can now use a salt tape, which is a transparent material, to wrap over a piece of paper, which is yet having the label on it, and in such a way that it doesn't block, or it still gives you the visibility. Now here is my piece of paper. I can showcase both of the two ways of labeling. This is a piece of paper, and I cut this paper into small pieces which will be used during labeling procedures. Here I cut a piece of papers, and I cut them into small or 10 pieces. And here, after cutting these small pieces, my purpose is to label them. I label the most possible labels I prospected to meet during the national examination requirements. So I have letters like letter K, letter P, letter S, and letter G, to mention a few. Now, like I said earlier, there are 2 ways of labeling. You might use a tape measure, a masking tape, sorry, or salt tape. A salt tape is a transparent tape which can be used when you're using paper labels to wrap over it without even blocking the letter visibility. Now here I'm going to showcase both of the two. As I said earlier, here is a tape, masking tape. A masking tape is mostly used to label hard materials like a wire. Now here to showcase, this is what we do. Say this is a hard material, I pick a masking tape here, and I put it over a hard material this way. Then I cut into a piece, then I label, say, letter K. This is one way. So now you can see already I have labeled my hard material. But next, I might use a tape, a salt tape. A salt tape, this is what we do. Excuse me, I might take this to showcase. This is one piece of a salt tape, and yet I have labeled it on a piece of paper. Here, this is letter K. So now if I wrap this over this letter, then you can see still I don't even forbid the visibility of this letter. So this is the useful way of using a salt tape, a transparent material which doesn't forbid the visibility of a letter. So these are 2 ways, 2 useful ways we commonly use during labeling during laboratory preparations. Well, now having seen the labeling procedure, which is one of the stages to undertake during laboratory preparation, now this is one of the most crucial and important aspects or stage to take over, the calibration process. And mind you, the laboratory preparation is aiming to make sure that a student is taking accurate and a correct measurement. To enhance this, you need to prepare instruments which are working properly. Its functionality is okay. It is the teacher's purpose or laboratory technician aspect to make sure that instruments, apparatuses, and equipments are working properly. Now, to ensure this, in addition to different apparatuses which have been listed in accordance to the National Examination Checklist, you need additional tools which will be helping you during calibration process. To mention a few, here we have the moving coil galvanometer, and we have the ammeter, we have a voltmeter, and this is the analog beam balance, and we'll see soon the electronic balance or digital beam balance. And I have a digital stopwatch here, and these are some of the apparatuses we are going to have an access on. How do we calibrate it before setting them ready for the national examination process, national examination takeover. Now, the calibration process is requiring the laboratory practitioner or the teacher to make sure that in addition to the laboratory equipment or apparatuses, you need additional tools which can help you to enhance the calibration process. This can be a set of screwdrivers, and we have here a pair of pliers, to mention a few, which can help you to make sure that the calibration process is made easy. Now, I will go to showcase on how do we calibrate one of the instruments during laboratory preparation. Okay, calibration process is involved with so many aspects to check out before setting the equipment ready for the examination. One of them is make sure that your apparatuses have got correct zero error adjustment. Now I have the ammeter here, and here is the voltmeter. And I'm going to showcase to show one which is having the correct zero error adjustment and the other is having incorrect zero error adjustment. Now, if you have an access to see these two voltmeters, one of it, if you have an access to see the voltmeter I'm holding in the right hand side, my right hand side, and here the voltmeter in my left hand side. The right hand side voltmeter is having the correct zero error adjustment. But if you have an access to the left hand side voltmeter, has got a bit deviation from the zero error. Now, it is now the purpose of the teacher in charge or the laboratory practitioner to make sure that all the equipments, all the meters have got the zero error, the correct zero error adjustment. Now, this is the purpose. Now, what do we do? We need this set of what we call the screwdriver. And have a look here. Every meter is having the adjustment knob. If you can have a look here clearly, this meter, the voltmeter, for clarity, is having one of a knob here at the rear side of the voltmeter, and it's having some kind of a track, a mark at the center, where you can place or insert the screwdriver and start now adjusting left or right to make sure that the arrow is getting to its position. Now, here is what we're going to showcase. Hold your screwdriver, and here is an incorrect zero adjustment voltmeter. My purpose here is to make sure that I insert this screwdriver here at the center of this knob, and I start now moving clockwise or counterclockwise depending on the adjustment, the zero error adjustment. If you can see here, the arrow is beneath or in front a bit from the correct zero mark. So what I do, I adjust counterclockwise to make sure that this is getting back to the zero position. So this is what I do. Roll it counterclockwise. Now you can see it's getting back till I get a zero yet. So here is the zero. The zero mark is yet attained with that arrow. Now here I can say my voltmeter is now going to take the correct reading because the zero error adjustment is made okay. This is how we adjust here. Now here, if you're looking properly, now it is a little bit beneath. Let me put it here. that you can view it clearly. It has gone a little bit far behind, so I pull it again clockwise now. Yes. But this isn't the right way of taking measurement. Mind you, we were instructed that the best way of taking measurement is to make sure that you avoid parallax error. Make sure that your eye is always set perpendicular to the reading you intend to take. So this is what you do. Make sure that your item to take measurement is before you, in front of you. Now set your eyes right perpendicular to the measurement to be taken, that you can see whether it is yet set to the zero error, correctly set to the zero error. This is how we set our eyes right perpendicular to the reading you intend to take. Well, now this is the right way, the correct way I was telling. Here is your voltimeter. Make sure that your eyes are perpendicular set on the measurement you prospect to take to avoid parallax error. But again, what I wanted to show, I was trying to show how do we adjust it to make sure that your meter, being the moving coil meter or a voltimeter, has got the correct zero error adjustment. This is what you do. Here is the knob I was trying to tell. This is the adjustment mode. It's having an arrow in between where you can place your a screwdriver. So this is what we do here at the center. Now you can adjust this left or right. Now you can see if I adjust left or right, it keeps moving. Now have a look. If I put it here, you can see this is incorrect zero error adjustment. So there's no way you can take the reading when this arrow is not pointing to the zero mark. So what the best way to do, because this has gone a bit forward after the zero mark, then you adjust it counterclockwise this way. Now you can see it is taking, you take it back to the zero position. Make sure that it is pointing exactly the zero position. There, exactly, and check out if it is exactly at the zero. There. Now you can see it is now pointing the zero mark correctly, just like this one here. Now this is now pointing the zero position. Now here you can take the reading. Now that was the part of the correct zero error adjustment. Another aspect to assess during calibration process is to assess whether you have a defective meter or a good meter. You might prepare an equipment or a tool which is not working, that when a student is taking measurement, there is no way he can get any reading, and he might end up frustrating during practical preparation. So what do you do? Here is one of the items or the equipments I'm going to check whether they are working or not. So what you do, this is an electricity equipment, so I need a dry cell to check whether when current passes, then it deflects or not. When it is deflecting, then that's a good one. But if it's not deflecting, then that's a defective one. So this is what I do. Let me start with the first meter. Mind you, the red knob here is showing a positive, and this is showing negative. Positive, negative. So this is what I do. This is the positive terminal, and this is the negative terminal. So I take positive to positive, negative to negative to check out whether it's working or not. So this is what I do. Now you see, there's no any deflection. That means this is showing that this meter is defective. Contrary to this, have a look here. What is happening if I do this much here? Yes, now you can see it is deflecting, so this is a confirmation that this meter is a good one. So I put it aside, that it is going to be used during the preparation process, but this is defective and I put it aside, then I don't need to use it. What if I check out for the ammeter? Positive to positive, negative to negative. Yes, yeah, it is also deflecting, so you can see this is also working, so it's a good one, it is going to be used. Now mind you, something to add up here, these meters have got two different scales. If you observe at the top part, there is one scale which is ranging between 0 and 1, but at the bottom one there is 0 to 3, so there are different scales. So it depends on whether what amount of current or potential is going to be applied in your circuit. So have a look here. If you are using this much, the top one, then you need to connect between this is the common one, and this is the knob which is showing the range, the highest possible range, 1 here. So if I connect here, this terminal and that terminal, then I use the top one because this is the 1 ohm range. I keep reading up here. But if I connect between the common and 3 ampere terminal, then you can see I keep taking the reading at the bottom or the lower part, the lower scale here. So you need to be careful when you're taking measurement that you might use the upper scale or the lower scale depending on the range of current which is passing. Now this is the useful or the better way of checking whether your meter is defective or it is the good one. This is what we do. Well, here is the beam balance. The beam balance is one of the common apparatus commonly used in the school laboratory, commonly found in the national examination checklist. Just like other items or apparatuses, you need to make sure that the beam balance is also working properly, assess its functionality. Mind you, we have 2 different types of beam balances, one being the digital beam balance or electronic balance, and then another is the mechanical balance or analog balance. Here is the analog balance. Like other items, you need now to calibrate, make sure that it is correctly taking the reading. What do? We have different adjustments over here. This is within a range of 0 to 100 grams, and this is within a range of 0 to 500 grams, having an interval of 100 grams from one range to another. This is having an interval of 10 grams in each. This is a range of 1 gram, having the highest possible range being 10 grams. So now these 3 are the use adjustment ways which could be helping you to take correct measurements. Now, how do we calibrate this? The digital balance is having a level or a mark which should always be pointing to the 0 mark here at the rear side of this balance. So what do? Make sure that the first aspect is to put all the slides at the 0 position. This one should be a range of 0 to 100 grams should be at the 0 position, and a range of 0 to 500 grams this should be also at 0, and the lowest possible also should be at 0. Now check out whether an arrow here, this mark is always pointing at the 0 position, just like other meters. This is what you need to assess. If it's not pointing, you have an adjustment knob here at the rear side, at the back side here, which is free to turn clockwise or counterclockwise. So your purpose is to roll it or adjust it clockwise or counterclockwise till when you suspend it freely, you can find that this mark is always pointing at a 0 position by using this adjustment knob. We will showcase on how we adjust this much. Next, let's go to the digital balance or electronic beam balance. We advise to use the digital balance during taking measurement of masses in the school laboratory, because in the school laboratory we are taking tiny loads or small loads to measure masses. This is because the digital balance is having high accuracies compared to the analog balance, which involves so many calibrations. Unlike the digital balance, you simply take a measurement directly. This is the digital balance, or it's also called the electronic balance. It has got also the same purpose to measure mass. Now it has got different different knobs up here. This showing the unit, and this is the mode. The mode button is used to identify whether you need to take measurement in terms of grams or in terms of pixels. You can see here, if I press this button, then I'm having different mode. If this much is coming, then the grams. But always you need to make sure that if you need to take a measurement, because we are taking tiny loads in the laboratory, the school laboratory, make sure that this is adjusted in such a way that it takes the gram mode, just like in here. So this is how I start taking the load. Like if I take this a pair of scissors and I put here, then you can see it is taking the reading 25.4 grams. If I take off, then before taking any further measurement, I'm having this button again, the tail button. If I press this button, then I'm trying to cancel the history that could be precisely being taken as a memory in this electronic balance. So if I press this much, then I can start taking another new measurement afresh. So someone has taken measurement and someone can come again, cancel the memory here, and take a new reading. This is how we use simply, unlike the analog balance, which involves so many settings and calibrations before taking measurement. And even the accuracy in digital balance is very high. It is precise and accurate that you are taking correctly the measurement. This is the digital balance. The stopwatch, one of another common apparatus which is very useful in the school laboratory, and it is always very significantly also seen in the national examination checklist before the 3 hours instructional preparation. The stopwatch is one of the common apparatus. This is the digital stopwatch. Also, the watches are of different categories. One of it is the digital, and also we have the mechanical watch or the analog watch. But commonly, we have been using the digital, just like I advised earlier on the balances, the beam balances. We usually recommend to use a digital stopwatch because it is also having so high precision and it is also accurate. It is also having the mode. You see, it's having 3 different buttons. This is the first button here, second button, and this is the third button here. The first button is the mode button. This mode button is used to set which mode you need to use your stopwatch. You need a stopwatch or do you need a clock mode? If it's a clock mode, then it's always there to check out the time, to measure the hours, the time in general. But the stopwatch is purposely used to find different laps when you are taking measurement, and mostly during heat experiments to take the timer or to record the time when you are recording different temperature variations. Or sometimes it is very useful in simple pendulums preparations when you are counting the number of oscillations, say 20 oscillations, you need a timer. So you simply click this much and it starts. Then you click the same button, it stops. Then here you can take measurement. If you need now to here take, it counts and stop here. It stops. Then you can take the precise time which is yet recorded. If you need now to restore, here is the restore or reset button. Press this button and you have zeros all the way through. You can see it is having zeros. Now here you can be able to start taking another measurement by simply pressing this button, the stop and the start button. This way it starts counting and you can stop it. There you can record your measurement. This is the stopwatch, which is also commonly used during laboratory measurement preparations. This is the digital stopwatch. Current electricity is another area of assessment, or a topic which is commonly assessed during national examinations, evaluation or assessment. And it is one of the topic which is having its apparatus being involved in the national examination checklist. Like other items, this is another area where you need to make sure that you have calibrated your instruments involving current electricity practicals. One of it is the meter bridge circuit. This is a circuit which is involving so many current electricity or electricity devices or apparatuses. One of it is the moving coil meter or moving coil galvanometer. And you need to have a key or switch. You need to have connecting wires here. You need to have a source of electricity or source of power. This is a cell. And you need to have a jockey. This is a jockey. Now, something to attempt here, how do we calibrate? This is very crucial and important to know. It has been one of an unsolvable paradox when it comes to calibration. If you need to enhance clear or efficient or accurate measurement involving current electricity, the meter bridge circuit is a vital role to check out. Now, what do we do? Because this is involving, it is involving on the relationship or matching resistance between one resistor and the other, then what you need to assess is, we are assessing the balancing point. And the balancing point should be traced in such a way that you need to check out what is connected in between the gaps. Here, this gap is whereby we connect a certain known resistor, and then another gap is whereby you connect an unknown resistor. Now, what is the easiest way of ensuring a very perfect calibration process. This is the best way. This gap here, you need to take a piece of wire, two pieces of wire of equal length, and fix them in these two gaps here. Why do we take two wires of the same length? Because if we take a wire of the same length, of the same material, say Constantine or nichrome, we know that these pieces of wires have got the same resistivity. Regardless of their length, they've got the same resistivity. Now, if we cut these wires of the same length, we prospect that these will be bearing the same resistance. So now, because we are assessing the balancing point, what we prospect is, when we be checking out the balancing point, we prospect because since these two gaps have got two pieces of wire coming from the same material and having the same length, that means they have the same resistance, then the balancing point should be at the 50 centimeter mark. This is what we need to ensure. If it doesn't work that way, then that meter bridge is defective. So now here, this is what we do. I have my pieces of wire. This is the first wire, a piece of wire, and this is the second piece of wire being cut from the same wire. This is nichrome wire to take as an example. This is nichrome wire having the same length as this wire being put in this gap here. So what I do here is to check out, because they have the same length, this wire and that wire have got the same length, and because they are cut from the same material, nichrome to be explicit, then I prospect, when I be looking for the balancing point along the sliding wire, then it will be pointing, or it will be balancing at the 50 centimeter mark. So now let's trace and check out whether it is balancing at the 50 centimeter mark. Mind you, we don't advise to use the standard resistors like this one, because these standard resistors have got different variations. This is reading, for example, this is reading 4 ohms, but if you measure it, you might find it reading 5 or 6 ohms. But again, if you take another here of a non-resistant 3, then you can find it doesn't give the same reading because of different circumstances. It might be the location where they were created, the environmental circumstances, the producer himself, and other circumstances of that nature. So we don't recommend to check or to calibrate the meter bridge circuit using the standard resistors because of those variations. We rather use the wires of the same length being cut from the same wire, having the same resistivity, to check out whether it is balancing at the 50 centimeter mark, because they have the same length and same resistance. Now, this is what we need to showcase here and see, does it balance? So now, this is how we connect it. I'm having a switch here, or key, whereby, and this is a key. If I connect it here, then I allow the flow of current to start flowing. Then I'm having the moving coil meter here, one knob being connected on the pathway of the current, and this one is connected to the jockey to complete the circuit and see the balancing point. And this is the gap where the first wire have been connected, and this is the gap whereby another piece of wire have been connected. Mind you, these two wires have got the same length, and because they are coming from the same material, they have got the same resistance, to ensure that when we be looking for the balancing point, then it is always balancing at the 50 centimeter mark. Now let's showcase and see whether it is giving us that balancing point. Now, calibrating the meter bridge circuit, we have two different accesses or two different ways on how we can check whether a bridge is working properly or not. We can simply use the standard resistors of the same resistance, or we can rather use two pieces of wire being cut from the same material, Constantine or nichrome, say. If you're using two standard resistors of the same resistance, what you need to make sure, that these two standard resistors are exactly reading or giving the same value as what is marked on a standard resistor. How do we go through? Use the digital multimeter, a multimeter, to check whether if it is indicated that it is a 4 ohm resistor, then a multimeter gives the same reading for ohm resistor, because there have been different faults within the standard resistors that you might find sometimes a standard resistor is being marked to 4 ohm resistor, but the deviation, when you read using a multimeter, the deviation is found to be big, say 7 ohms and the like. So if you don't have a multimeter, say, then we recommend to instead use 2 different wires of the same length being cut from the same material, say constantan or nichrome. What you do is cut the pieces of wires like this and connecting the first gap and the second gap and try to check the balancing point. But if you have recommended yet that the standard resistors are giving the same value as as it is shown by the digital multimeter, then you can also connect the standard resistors in two either gaps and check the balancing point whether it is reading at the 50 centimeter mark. Now this is how we showcase to find out the 50 centimeter mark. Hold the jock in hand and make sure that your circuit is complete and current is flowing. Here is the key, then I connect the key here, and yes, here now it is the verification that now current is flowing. Now what I check out here is to see whether it's passing. If I trust the direction and I see the deflection that the meter yes, I see it is deflecting that direction, and if I knock here, then I see it is also deflecting that direction. So what I look out here is to check, is it now balancing on the 50 centimeter mark or not, by simply checking out. Hold here, mind you, avoid dragging the sliding wire, because that is not advised because it has got different physical effects. So I keep tracing and see, check out here, check out here, check out here, here, yes, exactly here. So you can see this is giving you 49.5 centimeters. 49.5 centimeters. So now you can see the deviation is slightly small. So this is how we check out. Now we've seen how do we trace the balancing point and how do we calibrate the meter bridge circuit. That we always trace the balancing point, making sure that always when you are trying to find out using a jockey, then the moving coil meter is always balancing at the 50 centimeter mark, provided that you have connected in the left and right hand gap resistances of the same value, or using two pieces being cut from the same material wire. But now what happens if you have gone all the way through trying to check out the calibration process and that the balancing point is not attained at the 50 centimeter mark? What do? There are so many troubleshoots to go through. One of it is to make sure that the adjustment knobs here are not loose. Avoid the loose connection in these adjustment knobs. Tighten to make sure that there is no loose wire in here. You can use your fingers if they are that much firm, or you can instead use a pair of pliers. You can use a pair of pliers to a bit tighten, hold this one and roll it this direction to make sure that there's no loose connection in between here, which might give some kind of imbalanced troubleshoots. This is how we use this much. So you can use a pair of pliers, or you can simply use your fingers if you can hold them firm and tight. This is one of the possible troubleshoots which can lead to imbalancing point. But again, apart from these adjustment knobs, if you turn this bridge at the back, the knobs to tighten this wire. So you can use it to tighten this nuts up here. You simply hold it, find out whether sometimes they keep losing because of being used several times and they get loose. So what you do here, you have a pair of pliers, hold it and check out whether it is tight and firm, then roll it that way, make sure that it is tightened. Because if they get loose, then this can lead to imbalance troubleshoots. This is the meter bridge circuit, and this is how you can calibrate it.